To start, the nerve for 3D printing. Okay, so like everything, we've got challenges, and I joined a seminar once and they had a challenge which they put before us. So I will share that with you, with some of the challenges myself. So I'll make a start and introduce you first to 3D printing. 3D printing, I'd say it's been around since the 80s, but it's obviously developed a lot quicker recently because of the material technology which has progressed. So you can get anything now from a house down to micro devices printed in various materials ranging from concrete to plastics to metals to glass, you name it, you can pretty much get it. They've all got their unique properties, but it is still a growing technology which is diversifying into so many areas. So for me, myself, my background, I'm a PhD student studying 3D printing of solar cells. Very unique, but we need the energy. But this isn't the problem right now, so I will share the next thing. We've just recently had the one on bacteria. This has been highlighted recently. Pretty sure we're all familiar with COVID. 3D printing really came to the forefront with people 3D printing in their own homes, PPE for the NHS. This was amazing. It showed the versatility of the technology that anybody, anywhere can make something. So we here at WMG, we contributed as well. So we did some prototype devices for surgeons in London hospitals who were developing, doing their own niche things. We could make, so that device in the bottom left was made within 4 hours and sent to them. Literally, you send us a design, we can print it. There's no limitations on manufacturing processes. It's fairly quick and versatile. Surgery. Where do doctors start? You all go in for surgery, you've broken your leg, you've damaged yourself. You want to know that the doctor at the end of your bed has had some experience. He's practiced somewhere beforehand. You know that when you go to your mechanic, he's had training, he's had the practice with the car, he knows what he's doing. Your surgeon hasn't actually had the chance to say, hey, I'm going to practice this beforehand, or this is my first time, you are my guinea pig. Your nerves are going to be at their tether's edge. So generally, they practice an old school method, clay models, or cadavers, so a dead body that somebody has donated to science for learning. These are very rare. You can buy them, very expensive, high maintenance, hard to get, and once you've used one, you can't recycle, so you're limited. So these clay models can be quite time consuming to make, and they're definitely not realistic. So here, the image on the left is one demonstrator model the academic shared with us, and it's nothing in comparison to the real thing of what the doctors would see in, say, your hand, the nerves, the muscles, everything. It's very intricate. So unless you're willing to volunteer for a PhD student doctor somewhere, which I doubt you would want. You'd want somebody who knows what they're doing. You want them to be educated, you want them to be learned. You consider me, PhD student, educated, I know what I'm doing. So we all need an education to get to this point. You want to trust your doctor, he knows what he's doing. So what he's learning from somebody like me, hopefully I know what I'm doing. It's not entirely the case. Well, I do know what I'm doing, but I didn't go through the usual route. When I left school, I did not have A-levels. I was not deemed smart enough with maths, and I was told that I would need something more vocational, which is kind of a setback. I enjoy experimenting and having fun. So I went into industry, and now my background is a mechanical engineer. I went and joined a steam railway for over 10 years. So my background is Victorian railways. However, I had this amazing boss who showed me I had so much more potential and pushed me to the limit where I then went back to, I went to university and did a degree in engineering and furthered myself. So from my days as a Victorian railwayman to motorsport engineering and literally diversifying everything I could do and pushing myself. I've also done some experiments myself and been a guinea pig. So here you see some analysis on the brain within Swansea University. That was quite interesting because they actually put me inside a CT scan for that. So this isn't education, isn't boring. It's definitely fun. But then this is what I like. So, so how's this brought us then to this? Take into account this is my own journey. This brought me into the PhD of 3D printing. Now CT scanning technology is amazing. you can get a lot of detail inside. However, your average CT scanner for high quality, normally you don't want to be in there alive. So most of it is normally done on the higher resolution on parts of the body or animals, creatures, parts that are not living. So you generally need a cadaver to start with. So for this example that I gave today, I've got with me my finger, which I have 3D printed. I used a surface scanner as a proof of concept for this project for the academics to scan the outside of the finger. And what I've done is I've 3D printed this on a J750 printer. It is literally an inkjet printer, so this technology has been around for ages. However, what they've done is they've used a plastic that's light sensitive. Now this is a sped up, this is 2 hours in total print of this finger, or one of them, and how quickly it can happen. Now this is, like I said, 2 hours, and this allows anybody anywhere in the world with this machine to print this technology. Now the benefit of this is just a single color from what you can see on the outside. So what next? This is the finger. You can see the resolution on the outside, but right now you can't see anything inside and internally. Now my colleague Phil, you've already met, has got some of these. Now these materials change their properties. This is a standard color 3D printer. You can print in any color and you can change the rigidity of it. You can either have it as solid plastic, like you would your spoon, or you can have it as a rubber, very, very flexible, which means you can now start to play with the internal components of the finger and make the bones. You can make the bone solid, you can make the muscle a certain texture, you can make the skin the correct texture. There's a lot of detail inside though, changing the data from a CT scan into something you can print. But once it's done, I can send this to anybody and you can practice this. Now this one hasn't been printed with the inside, and I don't know if some of you are squirmish, so opening a fake finger might be enough to put some of you off. It would be cool to do mine. Not put you off. Okay, so anatomical 3D printing, we can now print the details inside. They might not be the real thing, there might not be blood pumping around. However, this is still a step in the direction of teaching the next generation of doctors who are going to one day stand at the end of your bed saying, I know what I'm going to do. This is what I'm going to do. They're actually going to know rather than have practiced on a clay model. So this will be available for everybody. So now, what used to be a degree level, you would be able to now pass it down to school level. So if you're in school right now, you're doing biology, you're taking apart maybe a frog in the science classes, you might be able to change that in the next 10 years because your teacher might have a 3D printer in the technology department and go, I found the CAD file for a finger. Belonged to Kevin once, back in 2022. He 3D printed it and is now used as a training model. Print it off, dissect it. This is where his nerves went. This is the unique feature. So I had an accident when I was a teenager and cut the skin just here. With my 3D printed finger, you'll notice that scar is still there. Okay, it's taken every detail. Once this file is available, it's there forever, and you'll be able to repeat it. So the current process is very lengthy, but it's getting quicker, and it's being broadened. With the change of technology, it's becoming more available. And this is where I came in, because this technology, when I say this technology, this step has come about because I introduced myself to it. I did something. And what I would encourage all of you, if you were at whatever level you're at, is question everything. We're all in this learning different situations. I got to this point by pushing myself, being pushed by others. And the only way we can develop anything and make things better is to work together. And we need you as individuals. So if you have any questions, please do ask. I love them, even if they seem stupid, because that's when some of the greatest ideas come together. This was me putting my hand up one day and saying, well, we can do that. As a result of that, academics have taken this, they've got funding, and they're going forward, which might be available now to you guys in 10 years' time, because somebody put their hand up and said, I can do this. Thank you.